Hello, my name is Russ. I'm going to show you some things about Kubernetes and some things about my setup in particular. So Kubernetes, first of all, that weird name is Greek for helmsman or pilot, or I've heard people say captain. It's KAS for short. If you ever see that, that means Kubernetes. So it's a system for automating, deploying, and scaling and managing containerized applications. So this is a sort of simplified diagram of a cluster with two nodes. Nodes are just VMs or physical servers running Linux and Kubernetes on top. I've heard you can even run it on Windows, but I haven't seen it. So Kubla is just the sort of the software that manages that node, manages Kubernetes on that node, you know, the point of it is to run pods, which run containers. You can run multiple containers per pod, and you can see, you know, this node only has one pod running, and this has two, and this pod has 3 containers, and you can tell that none of these containers are part of the same deployment, which I'll get into in a minute. You can tell that because they all have different numbers of containers in them, and each pod in a deployment has to have it has to be identical. So you can tell these are not part of the same deployment. And then the scheduler is you know, just the part of the system that you that schedules the pods that runs the pods on the nodes, and you tell the scheduler to schedule things by using the API, which runs on you know, the masters, and the nodes can be masters or just workers. So anyway, we'll get into that more. So it's originally designed for or by Google, but now it's maintained by the Cloud Native Computing Foundation. So why would you use Kubernetes? Well, for me, the biggest reason was the no outage deployments, because I was taking an outage every time I wanted to update my code. But other people, you know, want the easy horizontal scaling. You know, it really simplifies networking and DNS. It's portable, so if you build for Kubernetes, you can put it on, you know, AWS, Google Cloud Engine, Azure, and local, and put it on VMware, wherever. Let's see, self-healing. So yeah, if a pod dies, it'll fail its health check and it'll destroy it and recreate a new one. And yeah, it's a good way to do infrastructure as code. So I mean, let's see. Obviously, it uses containers, right? And so Kelsey Hightower puts it this way: like, containers are an image. Let's see, container image is just a packaging concept. Think of it as the price of admission for modern platforms such as Kubernetes. So here's how you build one. You'd create a Docker file. It's just a little text file that looks like this. You start from like a base Linux image. They're usually like stripped down, you know, the bare minimum you need to run some software on it. So they're real small. And then as it builds it, you know, at build time, it'll run these run commands. You know, this just actually just updates it and then installs Apache on it. And that gets layered on top of this original image. It's just the original image is just, again, Ubuntu Linux. And then, you know, each line gets layered on top. So this is just an itty bitty change. So this would be like a kilobyte or less added to the image to add an environment variable. So you got some environment variables here, and then you expose port 80. The idea is you know, this is a web server, and then this is the command that runs when you'd actually run the container. Now, one thing, this Docker file is what the Docker command would read and use to build the image when you'd run like Docker image build. and then so you'd end up with a image in the local file system on the Linux box where you're building this image, and then you could push that image to a registry, and it'd be versioned, so you can refer to that version in the registry, and the registry just has a URL, and there's a format for specifying the version. So here's like a Venn diagram of a cluster. So each cluster can have many namespaces, and namespaces are just like a DNS zone. It gets its own DNS zone. So anything in it can refer to other things in it with short names. Let's see here. You can also use namespaces as like security boundaries. So like this guy has access to this namespace and this guy doesn't. There'd be you'd use a namespace for each environment you might spin up, or each tenant. So like prod would have one and dev would have another. So deployments are sets of pods. Every pod in the deployment is identical, and you can scale them up and down. Like you'd have many pods or very few pods. Like your dev environment might have deployment, the same deployment, but with the number of pods within it might be smaller than your pod. So within each pod you can have multiple containers, but usually only have one, unless you can have like sidecar containers, which do things like firewalling or proxying, or shipping your logs off or whatever. Generally you'd have one application container in there. So then other things in the namespace are like services. So services are like little load balancers, but not like a F5 or A10. Well, first of all, services operate on like layer 4, and they operate within IP tables. So on each on each node, the service operates within its own IP tables, local IP tables. So it doesn't have to like go out to a pod or some sort of load balancer on another box and then get from there go to a pod or something. It goes directly using the IP tables on the local node. It can go directly to figure out where to go directly. Hopefully that makes sense. And then ingresses are another type of load balancer, I guess. There's a common type of ingresses just in Nginx, and ingresses are work on layer 7, so it can handle slash API or some other route, and you can do SSL offloading there too. So here's how you'd actually create your things or stuff on Kubernetes. Is just refer to a YAML file. -f means file, or I guess folder too, because you can point to a folder. Or even a URL. And here's what one of those YAML files looks like. Basically, there's a few different object types or kinds, and like I mentioned, there's one called deployment, and then you give your deployment a label so that your services can refer to the pods within it by that label, and other reasons to give it a label, I guess. Everything has a name, of course. Replicas, the number there is just how many pods you're going to spin up of this type. And here's the template for your pod. You're going to have just one container, and it's going to use this image. It's always going to download the image, and even if it has it locally cached on the node, so the container is going to have that name, TRIGGERcmd. It's going to set up some environment variables from the from this secret. It's got its own Kubernetes has its own secret system, and then I've got a couple probes. One, the liveness probe. If that fails, then Kubernetes knows to destroy that pod and create a new one in its place. Readiness probe is to tell the services when, to tell the service that this pod is ready to receive traffic. Notice it uses the same, just anonymously accessible login page to tell whether the pod is ready and working. And then DNS policy, that's like whether to look at your DNS server outside the cluster or the local DNS server. You'd always use cluster first. Image pull secrets. Oh yeah, so this Amazon Elastic Container Registry needs a username and password, so that's stored in that secret. So scaling, that's another thing you can do. You can just say, I want 20 replicas instead of the initial 2 that I had specified before. And that's the command you'd use. This kubectl is just a little binary you can put on Windows or Linux or probably other OSs, Mac of course. So yeah, you configure it. You end up with a .kube folder in your home folder, and it refers to that for the credentials to log into the Kubernetes cluster. Now services get a DNS name, so and this is important. That's why I wanted to slide on it. They get a DNS name within your namespace. So if you're I'll keep going. You've got a cluster namespace, right? Service.cluster.local, and then within that you got your specific namespace. Say I'm working in prod or dev, that would go here, and then my TRIGGERcmd service name would go here. So every container in the namespace dev1 gets resolve conf. That includes the DNS server and this search order. So dev1.service.cluster.local is where one place it'll search. It'll search that first, in fact. So when I want to refer to triggercmd.dev1.service. whatever, I can just refer to it by its short name. That's the important thing. So here's how services work. Again, it works with your IP tables on the local node, so it doesn't have to go out a node and back to get, or not back, but out the node. It doesn't have to take extra steps to get to where it's going, where the traffic's going. The configuration for that service gets replicated to all the different nodes. So if a pod on that node as a client needs to talk to a server that's behind one of these services, like one of these backend pods, then it can go there directly, basically. And again, this label tells the service which pods. Like basically, the service will load balance to all the pods with that specific label, and that port too. So here's the GUI. Although most of the time you won't use it, you'll use the kubectl command to interact with your Kubernetes cluster. But it's good to it's useful to be able to look at the GUI to I don't know, kind of get a people like to see pictures, I guess, to see how many pods they have, or you can look at the config pretty easily. Just clicking around it helps. So I mean, I'll use this screenshot to talk about the different components. So you got namespaces, of course. Talked about those already. The bottom 3 come with the cluster, and then I've got one for my database for my dev environments. They share it. They share that database, and then prod uses a Mongo service that points to an external Mongo database. I'll get into the different types of services in a little bit. So anyway, nodes, that's just listing your nodes. Persistent volumes are for containers that need to retain their state, so you can destroy and recreate your pod and therefore the container. And when it gets recreated, it'll reattach to a persistent volume, so it'll have, its data from before. Roles are just, it's got a role-based access control system. Storage classes, I haven't messed with that, I don't know where it is. You can set up cron jobs. Daemon sets are basically, you can set up your a daemon set to put a pod on every node in the cluster, as opposed to deployments that just say I want this number of pods, and then it just spreads them out somewhat evenly across your nodes. But not necessarily, like if you only wanted one, you wouldn't have it on every, you'd only have it on one node. But daemon sets, it'll put it on all of them. Jobs, you can run a container that just runs a command and then dies. So that's basically jobs. Pods, that's your deployments deploy pods, or daemon sets do too. Replica sets, I don't mess with those. I can't remember, but I think your deployments actually create them. And replica controllers, again, I don't mess with those, or stateful sets, I don't mess with those. Ingresses, again, are those layer 7 load balancers, basically. Like an ingress is often, it runs in a pod as like an Nginx load balancer, or it can be an external load balancer, like Google's load balancer system, or if Google Container Engine, or Cloud Engine has their own load balancer, so it would talk to that API to set that up. And then services. Again, there's a few different services types that I'll get into in a minute, and those are pretty core and key to Kubernetes. Config maps are just non-secret configuration. Persistent volume claims. Okay, so you have volumes, and then you have volume claims that kind of attach your pods, or your pods to your volumes. So here are the different service types. The default is cluster IP. It exposes the service to on an IP that's internal to Kubernetes. So yeah, Kubernetes gets this big like 65,000 IP subnet that all the nodes share, but you don't. It's not routed on your real network. It's only routed within the cluster, basically. And so the cluster IP will get an IP on that network, and then the node port basically exposes a port above 30,000 on every node in the cluster. And so if you let's see here, if you hit any of those nodes on that port, it'll basically enter that service, and then the service will redirect you to whatever pods that service load balances. Load balancer, let's see, a cloud provider's load balancer, kind of like the ingress type that's external. Yeah, I haven't used that, so I don't know much about it. External name, it's basically just a kind of a DNS alias, but yeah, so you'd hit service name.dev1. Cluster.local, I think, and then or just service name, okay. And like MongoDB is the service name that my app connects to, and that service name, if it's a cluster IP service, it'll go to the Mongo within that namespace. But if it's external name, then it can point to an IP or a DNS name that's outside the cluster, or even within the cluster. But anyway, it's just an arbitrary, sort of redirection DNS alias type thing. So ingresses work like this. You can have the internet come in to your ingress, and then it'll load balance to your to a service. But a single ingress can have, you know, multiple sort of routes. Like one ingress controller, like an Nginx ingress controller can have, you know, multiple services that it'll go to. Like /API will go to this service, and you know, just / will go to your Apache server or something. Let's see, API. So this is just the configuration for an ingress. You can see, you know, this one's a Nginx type. No, you can't see that actually. Anyway, so yeah, it would look something like this. Here's the host header that it's gonna expect the traffic to come in with, and if it comes in with /foo, it'll send it to this service on port 80. Simple as that. Here are some different ways to get to try out or to use, I guess, Kubernetes. You can use Minikube on your own computer. You just download this little binary and run like Minikube start, and it'll set it up. You know, you can use by default it likes to use what's it called, VirtualBox by Oracle, but you can use it with Hyper-V or whatever you've got local. You know, works with KVM, all sorts of stuff. Now, Google Cloud Engine, you know, that's, you know, Google's the original creator of Kubernetes, so, you know, that's a nice option. Azure has been gotten big into it, and then AWS recently, might still be in beta, started offering Kubernetes because they had their own system. Or you can use my script that uses sort of the official Kubernetes distribution, and then yeah, it's pretty basic, but you know, it'll give you, I've got 2 scripts there. One will give you a master, and one will give you a worker. That's all I had for the slides, but I want to show you my setup a little bit. So I'm going to show you how I can do basically continuous integration and I don't know if you call it delivery, because I have a manual step to do that. So yeah, I just made a little change to my README. It's a code change though, so I gotta, you know, check it or give it a commit message. Arbitrary demo change, whatever. Okay, now I'll push that to Bitbucket, and then in a minute it should call my webhook on Jenkins. There it is, and it's running that build, or it will anyway. So yeah, it's Jenkins is checking out that it received a webhook call from Bitbucket, and then it downloaded the code to the workspace, and you know, it's building the Docker image, which I can show you the configuration here. Let's see here. I forgot, I need to show you that in the Jenkins file. It's real simple. So yeah, it checks out the latest software or code or whatever, and then runs this command in this step, and then this script in the other step. Here are those. Let's see, build container. So it refreshes its you know, container registry secret, and then it deletes the secret on the cluster using the kubectl command, and then it recreates it using the new values, and then yeah, then it's basically, it just changes the deployment called TRIGGERcmd to use this container, which includes the latest build number, which is just the Jenkins, the next build number that Jenkins, has, and send it to this particular environment name, because I can specify which environment I want to deploy to. That's a parameter on my pipeline. Like I can say build with parameters and pick one. So let's see. It looks like it finished. Last success 2 minutes ago. So now that it finished, I can test this dev1 environment. I can refresh or whatever. Test a couple pages. It works. And then let's see, where was I? I can deploy to prod. So build with parameters, and then it's going to pick the latest dev1 pipeline parameter. But I can, if something goes wrong with that latest, build 28, I can go back to build 27 or even earlier. So I'm going to do that, and I'll go to actual production. Let's see here, and log in and just show you that nobody's nobody would actually notice the outage. I'll keep refreshing while it gets updated. Here, I can show you while the Jenkins job finishes like immediately, but it doesn't have to do much. It just tells Kubernetes to update the which container it's meant to use, and then you can see it's finishing up here, creating this container. It creates the new containers before it deletes the old, and the service is smart enough to know to not send the traffic to the new containers until they're actually up and running enough to pass the health checks. So yeah, here's the health check failing, but it has like a sort of a grace period, so it doesn't kill it right away. Yeah, alright, now it's done. These have been up more recently. And yeah, it works. I mean, I didn't continuously refresh, but trust me, I've tried that, and it definitely is no outage. So that's about it for my presentation. Thanks for watching.